Okay, so welcome to the solution for CCC 2023 S1 and J4. I'll be showing you the solution idea and I will be solving it in C++ and Python. Okay, so the problem is that Bocce the builder has just finished constructing her latest project, a pathway consisting of two rows of white equilateral triangles. However, at the last moment, disaster struck and she accidentally spilled black paint on some of the tiles. Now, she must purchase warning tape to block off the wet areas. Can you help her determine how many meters of tape she needs? So the first triangle will always point upwards, and any pair of adjacent tiles, that is, tiles that share a common side, will point in opposite directions. So if I have a triangle pointing upwards, and then I have a triangle next to it, that triangle will point downwards, and vice versa. So uh, every triangle, it says, has a side length of 1 meter. So the first line will consist of one integer, c, which is the number of columns, because the columns will be variable. But we'll always have two rows that will have multiple columns. We'll have varying columns. Um, so the next two lines, two rows, will each consist of c integers separated by spaces. Each integer will represent the color of a tile in the room, with 1 indicating that a tile is black and 0 indicating that a tile is white. So the following table shows how the available 15 marks are distributed. Okay. We don't really care about that very much right now. Here's the output specification. So uh, the output will just be a single integer, which represents the length of the tape that Bocce needs to fence all the area. Here's an example sample input one. So here we have we have C equal to five columns, two rows, three wet tiles, as we can see here in this picture. And since we know that each side is 1 meter, we have three triangles that don't share any sides. We will have 3 times 3 equals to 9 meters of tape required. Does that make sense? Now we'll go to sample input 2, which has C equal to 7. And here's the picture. So here it gets a little bit more complicated. We have this one triangle that's alone. So this will need 3 meters of tape since each side needs to be covered. But then we have these three triangles here which actually share sides. So we only need, instead of having 9 meters of tape for the three triangles, we will only need 1, 2, 3, 4, 5 meters of tape. Then we have 5 plus 3 equals to 8 meters of tape required in total, which is the answer. Because 5 meters is required for this component, and then 3 meters is required for this component over here. Okay, so that's the explanation for the whole problem. We'll go into how we can solve it now. So let's open Paint, and let's think about how we can solve this problem. So um, at the very start, we can think of this as like a grid, as a 2 by C grid. So let's go ahead and have a 2 by C grid. So there's going to be, there's going to be two rows. And let's just do 7 columns just because let's just do the same one that we had here. Sample input 2, so we'll have 7 columns. Here. So we have 7 columns, 2 rows. The black ones are 1, 2. So 1, let's call this black. 2. We have this one that's black. And then we have this one is black. I think that's all of them. Yeah. So that's what it looks like for us. Think of it as a 2D grid. Even think of it like one. Let's say this is a one, this is a one, this is a one, this is a one. Okay, that's how it works. So think about what happens, how we can reduce. So by default, we know that uh, every tile will need 3 meters of fencing. We know that by default, every if you ignore all these other factors such as tiles being adjacent. If you ignore that other factor, then by default, all tiles must have 3 meters of tape to cover to border them. Um, so we just need to figure out how we can reduce that 3 meters to a lower number. Uh, so by default, this tile, for example, needs 3 meters of tape. This needs 3 meters of tape, and so on. So um, the way we can have it reduce is um, okay. So if this tile, let's look at this tile just as an example. Let's assume for 1 sec. Well, let's just do this tile. This tile here. This one is a black tile. We know what this is a black tile. This is a wet tile. How can we reduce it? We look on the left. We say, okay, on the left, is there a black tile? And we see no, there's no black tile on the left. Okay, we move on. Is there it's not sec. So we can have tiles being under us, like this one, next to us, like this one. This one doesn't actually help us at all. So the tiles that help us are, for the first row, the tiles that help us are the tile on the left, the tile on the right, and the tile under us. The tile under us only if we are facing upwards. And we're facing upwards if we are odd. If we are an odd number, we're facing upwards. For example, this here is an odd number. This is the third one. So this is 1, 2, 3, 4, 5, 6, 7. So if our column number is odd, then the one under us also. So let's make some criteria. When can our number of needed tiles be reduced? So when can that number of needed tiles be reduced? Always, no matter what. Um, the ones on the two adjacent ones on the left and right, always the ones on the left and right, right? Always, that'll always be the case. Then also, so we'll do top row first. Top row. Top row for the 2 rows only. So that's the first case. Second case we'll make is so always on the left and right. If column number is odd, bottom one also can reduce. And what this means is, for example, if you're at this tile, if this tile here is facing upwards, then this tile on the bottom can reduce this one tile over here, right? This can reduce this tile. So that's pretty much what all it means. We no longer need this tile over here. Okay. So if column number is odd, then that works. No other ones will work. And look at the bottom row. Again, always the ones on the left and right can help us reduce the current one. Now, if the column number is odd, the top one can also reduce. However, if the column number is even, then the top one doesn't help us much, really. So only these are the only cases, really. So this here, right here, is the answer, more or less, to solve this question. This is the basic rule that we have to follow when we're solving this question. We'll go ahead and solve this in Python first. Copy this idea so we have it. Alright, so that's the idea. Let's go ahead and solve this now. So we have to read an integer c as the number of columns. C equals to int input. Read that. And then we have row 1, row 2, We read row 1, read row 2. Or we could even just have a rows list, which maybe has uh, maybe 0 for I in range, or 3. We need 3 for I in range. We're just going to call this needed. How many are needed? C for I in range 2. 3 for I in range C for I in range 2. Now we'll have a wet row. So wet will just be the same sort of thing. It'll be 0. Wet will just tell us, is it wet? That's all it tells us. For 0, so it'll be this should be ending here, I believe. Let's just print out what needed looks like just so we're clear. Let's do 5. So what we want is we want 2 rows, 10 numbers in total. So we want this to be its own row. Here we go. So 5. There we go. Now we got what we want. Okay, so that's needed. Now we'll make a list called wet, which will just be the same thing. 0 for I in range C for I in range 2. This is obviously much easier in C++ because this is how we do it in Python. Okay, so that creates the wet needed array, the needed list, the wet list. Now we can go ahead and solve the problem. We need to read, obviously, for I in range C. C, we will just read in needed I. Maybe you can even just do for I in range 2, and for J in range C, we'll just do needed I J equals to int input equal. Sorry, it isn't needed. So needed we don't need to. We'll say okay. So we will have 2 lists. So we'll have row equals to list map int input dot split, and we'll do wet I do for J and row. For J and range row, we'll do wet if just do wet ij equals to row j. That's it. Okay, so we read in the wet, if it's wet or not wet, right? Try running it and see if we got that part correct. The practice. This cannot be for range len row. There we go. Okay, so that part's correct. It's good way to just run code to see if you're correct or not. So fix errors as you go. The next thing we need to do is actually implement this idea, which is we'll first go through the top row. So we'll first go through I equal to 0, and what we'll say is always the one. Okay, so we need to go through C times, and what we need to do is Hmm. Okay. So if I not equal to 0, then if and so the one on the left should not be 0, and the current index should not be 0. Sorry, the current column, and then also the one on the left, uh, and so needed, so very wet 0 I minus 1 is wet. Then what we'll do is we'll do needed 0 I minus equal 1. The same thing, we'll say if I is not equal to C minus 1 and wet 0 I plus 1, and we'll do needed 0 I minus equals 1. So always the two on the left and right can always help you. Then we'll do the one below you if you're odd. So if I mod 2 equals to 1, if it's odd, then and the one under you, so wet 1 I is so it's wet under you, then needed 0 I minus equal 1. And we'll have to do the same thing for second row. And then this will become 0, 1. Okay, so then we need to go through all the wet ones and calculate how much tape each of them need. So we'll just do for I in range 2, for j in range C, if wet ij, print, sorry, sum, we'll add sum or total or something, and we'll increase it by needed I and j. That's something called total down here. And we'll just print out the value of total. See if that works. Oh, what? Needed 0 I minus equal 1. Let's print out needed 0 I is. Some debugging. Okay, so needed 0 I is equal to 3. Okay. So I don't think you need these then. Yeah. So there we go. We don't need this anymore, and we have 9 as our answer. Now we will try this one. Should get 8 as our answer. We got 10, that shouldn't happen. Let's see. So, what do we get just using the top row? We should actually print needed ij. Be a good way to debug this. So needed for this third one is 1, and the second one, okay, 2, 2. So it's 2. Okay, so this one needs 2 because it should need 1 though because it has 1 under it. That's weird. Let's see here. So we'll say if I is equal to 3 or 2, print here. That actually if it actually reaches there. It doesn't reach there. Okay. 0, 1, 2. Yeah, it should be. There you go. Okay, so because I here at 3. Oh, I see. There should be I plus 1. That's the issue. This should be I plus 1. 8. Now we get 8 for this one. This should still output 9. Shouldn't be any different. 9. Let's submit this and see what we get. And Python. So you can see AC just means all correct. So we passed the problem. We got it. We got the correct answer. And that's the code. So here's the code. If you want to copy it down or read it, that's the idea. And now we'll go ahead and we'll write the same thing in C++. Okay, so C++ is the same thing, just same idea, just different language. We'll also just copy this idea because this is helpful. Okay. Okay, so that's the idea. Copy it out. Include its H, the competitive programming library, space std, int main. Go ahead and start. So iOS, Single Studio, false, cn.py, no ptr. Okay, let's get started. So, objects being an integer c, it'll be an array called need. I need the maximum value 200,000. So the maximum value will be 200,000. And if you don't want to see the C++ solution, you can leave the video now, but this is just going to be the same thing just in C++ if you want to see how we would solve this in C++. This should be 3, 2. Okay, same thing. 0, 1, and mm is just the maximum value it can be. 2b5, that's enough. Okay. So, and we'll also need a boolean. We'll use a boolean. And what we'll do is we'll go ahead and we'll read in C. Then we'll go ahead for I equal to 0, I less than 2, I plus plus. And we'll go through this many times. And then what we'll do is we'll just say cn wet I j. There should be a j, not I. That's it. Okay. Here we've read everything. So we'll go ahead and we'll just do this thing for the first row. Use the idea for the first row. What we'll do is we'll say, okay, if I not equal to 0 and wet 1, wet 0, 0 I minus 1, then we can go ahead and say minus minus need, call it need, right? Yes, need I j. And of course, initially everything should just be 3. So if we just do the same thing here, initially everything should just be C. Okay, let's do that. And then if I is not equal to c minus 1 and wet 0 I plus 1, then you can go ahead and do subtract need I j. Need 0 I. Alright. Now we'll move on here and we'll say the bottom one. So if if wet 1 I and I mod 2, so it's odd equals to 1. Don't need to add the equals to 1 even. That's enough. We'll subtract from need 0 I. The same thing for the second row. Copy paste it. Same idea. All we do, and then we just do and total. So we'll create integer total equal to 0, and we'll just do for int I equal to 0, 2 I plus plus, for int j equal to 0, j less than c, j plus plus. Say if wet ij, if wet, we'll just do plus tot plus equals need ij. And all we do is just output the tot. That's all we do. So the answer for this should be 9. First input should be 9 once it runs. There we go. 9. Second one should give us 8. If that's correct, we can submit and see if our code is correct. It should give us 9. Oops. There. 8. Okay. So that worked. Let's submit this and see what we get. So we can see we get all correct. So that's the code. You can view the code. I'll give you 2 minutes to view the code. So that's it. That's the solution, the idea, and the implementation in Python and C++. You can try it out on dmoj.ca/problem/CCC23S1. And you can view the solution. You can view the top solutions right over here in both Python and C++. Thank you.